We're talking about logarithms, and you got to remember that when we're talking about logarithms, we're talking about an exponent. Log, exponent, those two things are related. They're related kind of like multiply and divide, but they're definitely related. When we're talking about logarithms, we're talking about exponents, okay? And so what's kind of tough about today is it's weird when we see a natural log, but in yesterday's lesson, we might have seen a log base 10 or a log base 7 or a log base 4 or a log base 12 or a log base, whatever, log base 19. We had all these different bases. The common log, if it just said log, we're supposed to understand that that's a log base 10, all right? But a natural log is another special one, kind of like the common log is base 10. A natural log is going to be base E, all right? And E is a weird number. It's Euler's number. If you look on your calculator, you probably have an E button. So if you say E to the first power, that tells you what that tells you about what E is. But in this problem, when we're doing a log base E, we're doing log base 2.718 blah 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 blah. So that's kind of weird. Log of 2.718 dot dot dot. We're not going to write all that down. We would think about it as log base E. Log base E has a special notation. Okay, we don't really need to write log base E because it has its own notation. Natural log, you've got an N and you've got an L. So it would make sense if they abbreviate it as NL, but they do it backwards. The log base E instead of NL is LN. So when you look at your calculator, on that same button where I had the E, look at yours, see if it's the same thing. On the same button where you can access the button, the E, you should also have an LN. That LN stands for natural log. And so your natural log is a log base E. It even says so on your calculators. Okay? So the easy part of problem number 1, that says natural log of 31, we can just hit that on our calculator. LN 31 is 3.43. It says round to the nearest thousandth, so that's 3 decimal places, 434. 3.434 on there. 3.434. All right, now remember what we're finding. When we're calculating a logarithm, we are calculating an exponent. We're finding the exponent that makes 31. So even though we don't have to do this, we can do a check and say E to the 3.43398 and so on and so on. That's your 31. The only reason it's not equal 31 is because I rounded off, but that's your 31. We're looking for the exponent that makes 31 with a base E, of course. So then ln 3.15, the easy thing is you just have to type it in. ln 3.15, 1.147. 1.147, and again, that's the exponent that would make 3.15. When you get to number 5, we're solving, and this should remind you of a problem that we've done before. We want to try to isolate the variable, but we've got to get rid of the logs first. And so normally what we did is we took whatever the base was, we took that base on both sides. Well, in this problem, it's a log base E. Ln is log base E. So what I'm going to do is take a base E on both sides. Now in this problem, that doesn't really do anything for me other than that just cancels out my LNs. That cancels out my LNs, and I would be looking at negative 3r minus 3 equals 2 minus 2r. I'm going to solve this equation here. What I like to do is I take the smaller variable term and work on that. So I would take this 2r, and I would add 2r over. Whoops, that's not the smaller one, is it? The smaller one is -3. Oops. So it doesn't really matter, but I think the easiest thing to do is take the smallest of the variable terms and work on that. So add 3r, and then ISO the variable. I'm going to subtract 2. That gives me -1 equals r. R equals -1. So then the next problem is really the same thing. We're going to do a base e on both sides to cancel out the logs. I'm looking at 1 minus 3r equals 5r plus 1. You don't have to do it this way. There are other ways to do it, but I would add the 3r. I like doing that because a lot of the times it helps me avoid negatives, and it's just easier to handle numbers that are positive. We've got 1 equals 8r plus 1. I'm going to subtract the 1 over. Sometimes people get confused, but that's 0. 0 equals 8r. If I divide by 8, 0 divided by anything is going to be 0. R equals 0. Now, solve each equation round to the 10th, the nearest 10,000. That's 4 decimals. So I'm trying to isolate the variable here. That's what we're doing when we're solving. 9 times out of 10, when it says solve, it wants you to ISO the variable. So in order to ISO this variable, I'm going to have to get rid of a log. Remember, natural log is log base e. So if I want to get rid of that natural log, I'm going to take a base e on both sides. Now, this is important that you know how to do this, because in the last problem, it canceled out. But in this problem, it only cancels out on one side. I'm looking at n equals e to the first power. All right, do you guys remember what e to the first power is? 2 point something, yeah. So we're looking at Euler's number right there, 2.7183. Remember, it said round to 4 decimals. 2.7183. N is about 2.7183. So then if we look at the next one, all we have to do to ISO is take a base e on both sides. That's going to cancel my log. And x equals whatever e to the 4th power is. 54.5982. Right? Because that 5 is going to push us up. But yeah, very good. X is about 54.5982. Okay, so that's kind of the guts of it. We're going to have to do a base e. A natural log has a base e in it. This is just the exact same problem, right? Going to do an e squared. 7.3891. 7.3891. That's too easy. All right, let's crank it up a notch here, right? But we're still doing the same thing, right? Same thing. Base e on both sides. To cancel that out, I'm going to have -5p equals whatever e to the -1st power is. And so let's figure out what e to the -1st power is. Is that going to work? Oh, there we go. Ugly looking decimal, but that's fine. Remember what a negative exponent does, right? Negative exponent flips it. So 0.3679, 0.3679, 0.3679. But this one has one more step. What else do we have to do? Divide by -5, correct. So remember how that answer button works. I'm not going to type in that whole number divided by -5. I'm just going to type in divide, If I hit the divide, it's going to pull up my answer. Okay, so just take that answer and divide by -5. That way I don't have to worry about rounding off until the very end. Negative 0.0736. P equals negative 0.0736. Is that what it said? Yeah. Next problem looks like the exact same thing. We're going to do a base E on both sides. We already did e to the fourth a minute ago. It was 54 point something, I believe. 54.59. Okay, so negative 5x is about 54.59. Watch this. I'm going to be lazy. I'm not going to write down the whole thing. I've still got it in my calculator, right? I'm going to divide by -5, right? We're going to divide by -5. So, but I'm just going to be lazy with my work there, and I'm not going to write down everything. Divide by -5. I've already got that in my calculator. So if I just take answer, divide by -5, that's my answer. Okay, you don't want to round off in the middle of a problem. I don't want to type in 54.59, but as long as I've got that in my calculator and can divide, it's all good. X is about -10.9196. Negative 10.9196. All right, so then the next one, I'm going to do a base E. That's going to give me negative 10n equals, what was that, e to the negative first power? 0.3679, 0.3679. Divide by -10. You should be able to do that without a calculator, because that's just going to move the decimal. N is approximately negative 0.0368, right? We're going to divide by -10. It's just going to move the decimal. Negative 0.0368. Got it.